Welcome to our video on material synthesis techniques. In this video, we will explore various methods used to create new materials with desired properties in different industries. So, let's dive in and learn about some of the most popular techniques that have revolutionized material science. One of the most commonly used techniques is chemical synthesis. This involves combining different chemical elements or compounds to create new substances. By carefully controlling the reaction conditions, scientists can manipulate the arrangement of atoms and molecules to form materials with specific properties. For example, the synthesis of polymers like nylon or Teflon involves the creation of long chains of repeating units. This technique allows manufacturers to produce materials with desired properties such as strength, heat resistance, or flexibility. Another technique is electrospinning, which is used to create ultra-fine fibers. In this process, a high voltage is applied to a liquid polymer solution, causing the material to form a jet that is then collected on a rotating drum or a target surface as a finely dispersed fiber. The resulting fibers have a high surface area to volume ratio, making them useful in applications like filtration, tissue engineering, and composite materials. Electrospinning is a versatile technique that allows for precise control over fiber diameter and alignment. Next, we have vapor deposition techniques, such as physical vapor deposition, PVD, and chemical vapor deposition, CVD. PVD involves the deposition of thin films onto a substrate by physical processes like evaporation or sputtering. On the other hand, CVD relies on chemical reactions taking place in a gas phase to deposit materials onto a surface. These techniques are widely used in industries like electronics, optics, and coatings to create thin films with specific properties such as conductivity, transparency, or wear resistance. Moving on, let's explore additive manufacturing, also known as 3D printing. This revolutionary technique allows objects to be created by adding layer upon layer of material, unlike traditional subtractive manufacturing methods. Various materials, including plastics, metals, ceramics, and even living cells, can be 3D printed. The ability to create complex geometries and customized designs has made it popular in fields like prototyping, medicine, and aerospace. Lastly, nanotechnology has opened up new possibilities for material synthesis. Nanomaterials have unique properties due to their extremely small size, typically less than 100 nanometers. Techniques like bottom-up fabrication and self-assembly are used to create materials at the nanoscale, enabling enhanced properties like higher strength, improved conductivity, and increased surface area. Nanomaterials find applications in fields like electronics, energy, and medicine. In conclusion, material synthesis techniques play a crucial role in creating advanced materials with desired properties for various industries. Whether it's chemical synthesis, electrospinning, vapor deposition, additive manufacturing, or nanotechnology, these techniques have paved the way for countless innovations. By understanding and harnessing these techniques, scientists and engineers can continue to push the boundaries of what is possible in material science. Thank you for watching, and we hope you found this video informative and engaging.